Okay. Many of you, not all of you, but many of you were on the call. I guess it was late last year. So I'm just going to pick up mostly where that left off, and I'll get right into the demo piece since that's a lot more interesting probably than any of my slides. I'll just give you a quick summary of stuff, and those of you maybe who you probably all know the basics of SQL, but I'll just step through it real quick just to draw a contrast between what I'm doing and what SQL is intended to do, and also to let you know kind of the way that the order of evaluation works and ties into everything. And then I'll just talk about some of the stuff will come in future versions of this. Just real quick, the goal of this, and has been always for me, really, is I don't really care about databases. Databases have SQL. It's the standard language. That's the S of SQL, right? And people are very comfortable using that. That's the de facto language for databases, right? What I am attempting to do with this project is what I'd like to do, kind of in keeping with the Minecraft of programming kind of ethos, is create a dialect, a domain-specific language, and be able to kind of apply that in many different contexts. So it would be used potentially as a model. I think one of the shortcomings or omissions, I would say, of original Rebol is that it sort of brought us to the doorstep of what you can do with dialects, but it never really pointed the way forward with that. It just gave us some of the tools, introduced parse, which is fantastic, of course, I think we all agree, and then said, oh, and you can build dialects with parse. And they built VID and a couple of dialects, but nothing that really kind of, I don't know, when I looked at VID, and many of us probably have poked around in it, especially Chris, it's quite a beast, and it's nothing that I think I would ever look to model, and I don't think it was ever intended as such. So my feeling has been that many languages out there can create, you can create many languages out of them. Many languages let you do dialecting. Rebol has some pretty amazing features and that are quite amenable to this area. And unfortunately, I think it's a missed opportunity to date with its ability to dialect, and I'm trying to address that. So this, just to summarize, really, I'm going to show you a dialect using the syntax of SQL. I'm taking the simple English-like, very well-known syntax, which is applied in the domain of databases, but taking that out and just using that language layer to attempt to kind of consolidate some of the different syntaxes that accompany Unix-style text munging, file munging utilities. There's there's awk, grep, sed, cat, find, and a dozen others. I mean, there's so many great tools in the Unix toolkit, and I have nothing against those, but they're all different syntaxes with their own switches, and it's very difficult, in my opinion, it's very difficult for a new user or sort of a business user rather than a hardcore developer to, I think, harness the power of all those different syntaxes and to be able to produce results without kind of cracking open a manual. Now, if you're a sysadmin, of course, you don't have this problem at all. If you're one of those neck-bearded Unix guys, of course, your whole background is steeped in the knowledge of this dark art, right, of all these utilities and so forth. This is not for them, right? What I'm trying to do here, just to restate, is take this simple and probably the most successful dialect syntax ever created, and be able to apply that in that same space for file and text munging. So But I just want to make a useful dialect out of this first model, and it's the model that's important, not the SQL features themselves. I mean, I'm hoping that this will be useful, and we agree that maybe some or part of these, what I show you here, we might use directly in Ren-c and serve that up as some kind of prototype that anyone can use for file munging within Ren-c, so that you don't have to resort to other tools or build your own. Or these, I think or what we have here is, it'll be useful and serve as sort of like a way to create your own dialects, which may or may not have anything to do with texting, with parsing and file munging and so forth. It's a way of creating your own system of clause-based and keyword-based dialects. So my updates from the last time we took a look at this, I added some, I'm going to refer to a handful probably of Unix utilities in this. But one of the things I think Graham had mentioned was, it would be great to, I started with just what was available in file metadata. So when you query a file today, or you query a particular asset or resource, a standard set of fields usually comes back from the query function in Rebol. So I kind of stuck to that, because this version of the query was, I was thinking that we would just sort of keep it to that limited universe, which is fine. But it gets more useful, right? The more you go beyond the very few number of fields which are available in a query from any file resource. There's only about 4 or 5 things that are available. There's the file name, there's the file date, there's the file size, there's the file type, which is usually file or dir, I think. There may be one other, I'm trying to remember, but it's, it's really not a lot of values to work with. So for this version, I'm going beyond that a little bit, so that you can perform text searches, even recursive ones, right from your select statement, which is the very topmost output statement of a SQL expression. I've also added a number of things, or fixed a number of things in my where clause. The where clause is the filter of a SQL expression. And so I'm allowing between statements. So, you can say between a certain date, if you're looking for a file, for example, or there are other versions of between as well, any given value or digit, I added something called contains, and contains, this would be an example also of being able to add your own stuff to this. Again, any dialect model, you ought to be able to put in whatever you want. Now, SQL, you can't add whatever you want. It's an abstraction layer over a database engine. Everyone implements more or less the basic SQL standard syntax the same way, but different vendors, of course, have extended it with customizations to achieve different types of operations on the text. So, but you can't change the way the syntax behaves, or add your own clauses if you want in SQL. But this is a dialect, and this is Ren-c. So it's highly dynamic, and you can add and change things however you see fit. So one example would be a very small example. I said, well, I want to be able to filter out the output that comes from a query by a little string of text. And that's distinct from what you see in the select, because things that pass through the where clause are available for you to select and make changes to. Things that do not clear the where clause, it's basically a little filter. do not reach the select clause for output. So this is an earlier stage in the evaluation of a SQL expression, and by adding contains in there, you are already filtering the output. And since I have added the fields, I mentioned that originally we had just the metadata information for any given file, such as name, size, date, etc. So I added file text to be a new one. So that is it will do a read if you are searching on a specific or declare a specific value in here, which requires full text search. It will automatically add that in here. And this is, since that can add a lot of processing and time and processor to, if you have a very deep recursive search, and you just say select star. Select star is a shortcut way of saying select all fields. That will include that file text. It means you're going to open and read all of the file contents. So it helps in all cases, usually in SQL, to add a where filter. And in this case, because of the additional processing that would come along potentially with opening every single file and reading the entire contents, contains is one that you can make sure that if you are reading in all of your file content, you can make sure that it does not pass a filter. So I can say contains very specific piece of text or a block full of different text items, and it will only allow passing that where filter if all of the items in that contains clause or expression or condition, I should say, are true. Previously, also, I didn't have my where clause allowing ands, so I could only add a single where clause, which meant, in the filter you could say size is greater than 0 or size is greater than 100 or any number. We'll step through all the different options there. But I was just focused on getting those basics working and in place. I have another version of the script that does more elaborate stuff, but I didn't move that over. So now I've moved this over, and you can put as many and clauses in there as you want. So you get to say, you can say between and contains and greater than and less than, or any logical operator, etc., whatever you might want, and it just chains them all together. Obviously, the more you put in a where clause means the heavier your filter is going to be, which can be a good thing. So that's the basic set of updates. I'm going to step through this real quick just to highlight a couple differences between the SQL that many of us are familiar with and the query, that dialect that we're looking at here. SQL, of course, is it's pretty much entirely confined to databases. Now, you can declare other data sources like CSVs and things like that, but really, it's your from clause is going to be a table name, and that's about it. There are different versions of SQL that some vendors use, and even in cloud databases, they've been using SQL, and that can be a difference there. But in general, SQL from is purely a table name. In this dialect, though, we are allowing lots of different things, and I'll be adding additional things to the from statement. You can search on files. You can also search on URLs, anything that is text-based, really. You can even, recursively go down on blocks and objects. I have prototypes of those working in my other dialect, not on this one, but I'll be adding those in here so that you can be able to search through any kind of text-based structure. Even Rebel code would be nice as well, to be able to query for things and get results back. It would be nice in the future to have some kind of codec. I know Red has these, but CSV and JSON would be nice. I mean, you can still get all of those today and search on them as a file, or even as a URL, it's totally fine. But they're not validated in the sense, they're not broken down and parsed in a way that that respects anything other than the fact that it's text. So it would just come in as standard text like you would see in any file here, and it would be up to you, of course, to then write very specific parsing rules once you've read in these files. In other words, we're not respecting the structure of these files. Same thing for XML, but in the future, that's something that is possible. Let's see, what else we got here? The where clause. Let me speed forward a little bit here. Where clause, I already mentioned, is a filter. In general, there are just a handful of important conditions that you can use in SQL. In particular, I'd highlight the like condition. So you say you select something, and then you say where the column name is like, and you can then use a wildcard. In SQL, it's a little weird. It's different from the wildcards that exist outside of SQL for some reason. They use underscores and percentage signs to represent the question mark and the clean star, the little asterisk, which is a little strange. But we support those, both of those in our version. We also add in some other nice things, such as bash style brackets and braces. We'll take a look at those. I have not yet added in a parse rule block, which would be nice. You can just kind of, you'll be able to just you'll just be able to say parse. You can say like parse and pass in a parse rule. At least that's sort of my plan. So we're strictly here a little bit more powerful, I would say, than anything in SQL, since the bash style brackets and braces give you a lot more kind of almost regular expression, like expressivity and match patterns. And then finally, we started with from, right, the data sources, and then we went to from is what sort of sets everything up in the order, the execution order of a SQL expression. It determines everything that follows it. A where clause then filters out all of the columns and the data that is coming from your from clause. And then finally select, which is like your output clause. At this point, by the time you are at the select, you're telling the system what you want to display to the screen. And SQL, basic thing, you're describing tables, right? So tables, if you think of them like a spreadsheet, they have column names. And you can also, if you like, you can just include some static text in there, and that will create a column that populates the entire result set all the way down with that same bit of text. So sometimes you could use something like that to join like tabs or something if you want. Maybe you're going to export this to a tab separated file or something. So, or maybe you want to just inject a column that has some information in it. So it's quite useful to do. And then you have column functions. And the column functions are a way of sort of overcoming some of the limitations of basic SQL. A lot of time you're getting the data out of your columns. They're in the select clause here, and you're pushing them out. But you want to do a conversion, or you want to massage that text in some way, or maybe you want to truncate something, or trim something, or get a substring, count the number of rows, and things like that. This is sort of SQL's way of cheating, and it's not that different from, let's say, if you're looking at the Rebol parse dialect. In the parse dialect, at every stage of evaluation, you can also include parens, a group really that allows you to use Rebol code in the middle of it. So it's a dialect, but that dialect doesn't do everything on its own. You can then inject some code to manipulate that data. So most dialects, and I would say most I would expect that most dialects are a way of simplifying things or trying to express something in a very specific, controlled way, and that often the process of that involves some trade-offs, which leaves some gaps. And you can overcome those gaps by allowing a type of customization, like the way the parse rule allows Rebel code to execute within steps of the parse execution. SQL does the same thing in a sense with the way you can create your own functions and apply those functions against the output of the select statement. So I'm using that a lot within this dialect. That whole principle of basically what I'm doing is I'm applying a SQL dialect, a SQL syntax layer, and it's not a perfect representation of the domain for file, text, and munging. So what we do there is we fill in some of those holes. I'm adding things in there like specific file and text munging features from Bash, or I'm adding in regular expression-like things in here, or grep type features to be able to scan for text very quickly. Those are examples of really making the dialect, compensating for some of the simplicity of the dialect, but giving you some extra tools to be able to achieve the results you want. And I think that's about it, right? So let me go over. I'm going to, hopefully you can see this. Can you guys see my screen still?
Yeah.
All right, I've opened this up in PowerShell. The reason I use PowerShell, or at least I have been lately, is because if I'm able to open up Rebel from Windows PowerShell, and if I do something and crash Rebel, I still have my entire transcript. Basically, everything that's in the console is there. I mean, Rebel quits and it's gone, but I still have my entire history. So that's why I'm using this awful color blue. I can probably customize it, but I haven't looked into that yet. So this is not very pretty at all. I mean, certainly if in spirit with a dialect, you should be able to do what you want with it. That's, I feel, the main benefit of using something like Ren-c or Rebel or Red. It's so hyper dynamic and flexible. In some ways that's a hindrance, but in some areas that's a real power. And I think being able to customize a language to do what you might with it really lends itself well in the domain of dialecting. So what I'm showing here is really just a raw display of output from queries, and I'm going to type a bunch in here, and you can see just how some of the different combinations of the SQL dialect and how they're being executed here. Nothing has to look like this. This is really just a bare bones kind of output to the screen. Ideally, you could add a new clause if you wanted, or you could add some new functions to the select clause. The select clause is really what describes the output. So you could do something like add a display clause instead. So you could say display and then kind of control your own formatting of the output here. So none of this is set in stone. This is really just showing you the execution of the way the query works. So just to look real quick at it. So I just call a query with an exclamation point at the end because there's already a query function. And this particular query is set up to just sort of execute everything as a native value of some. Obviously, it's in a block, so it has to be parsable data types. Let's see, what else should I point out about this? Select everything from my desktop. This is not recursive. Let's see what it does here. I feel like there's something else I'm missing that I want to talk to you about, but if I don't use the asterisk, I can also say something like file. I can say these are the individual names. Nothing really fancy there. These are just showing all the different kinds of fields. I haven't tried this today, but let me see how this is working. So let's say so, I mean, I was just showing an example of what I did. I just injected a column here, which is going to appear in every single row of output. And I could just do that arbitrarily in here in the select statement and put whatever I want in there. I'm using a group to call that out. I'm not really thrilled with using a group for that, but I'm sure Brian lives this nightmare all the time. There's only so many different value types and symbols that you can use, so you kind of have to pick and choose. And I had some other, if I'm going to do a grep, for example, so let me do a grep kind of thing here. So okay, so that's a little confusing because I just injected that here, but this is a grep just takes a standard text and uses that as the basis for the search. So I had to decide for a standard piece of text that I want to inject, I needed to distinguish that in a different way from a greppable piece of text. So that's why that's in a group. But all this stuff can be changed around. It's really just, like I was mentioning with Brian, sometimes you have to try some different things and see how well it settles and see if that's a good solution or not. So some of these lexical forms will change most likely. So let me keep getting a little bit more interesting with some of these. I'll point out that once you add a greppable search string, it's going to rotate the data. So if you are used to SQL in databases, right, you're always going to get one row, or you get nulls, but you're going to get one row per result, right? But notice what happens in this result. Now we're going to more of a grep style search, and it's automatically going to show you the instances of this grep text here, and I just selected something random, and now I'm getting multiple hits within the same file. That's different from up here where I didn't do a grep search, so it just showed me the file that came back, any file that came back. Now it's showing me the instances, the number of occurrences here. So it's kind of rotating or transposing the data so that it is populating based on the number of times this string is found. And I can put multiple of these too. I don't know what happens if I do. So, I mean, I'm getting more, right? Because what happens is it's doing an OR. And this is like grep. So it's finding any occurrence of an or the in my file. And now you see things are, just getting longer, right? Okay, no real surprises there. I just wanted to point out that we're making SQL do grep-like things. And that's I use this kind of thing all the time anyway, even with databases. I will search for something and then I'll just populate the metadata populate throughout all of the rows of results the same data, just so that but that is not something that's standard and easy to do with SQL. Okay, let's keep going with a couple more interesting searches here. The file name. Name is the full file path. So I'll say deep. If I add a deep in here, that's just recursive. Go on for a while. So this is going through all my files. Deep is a little bit dangerous here. I need to add some error handling here. There are things like in Windows in particular, but this will exist in other systems. I don't yet have error handling in here for directories which are not allowed, or files or resources which are in use. They'll therefore will be locked. So eventually this can keep going and keep going and keep going. And then it'll hit my OneDrive. OneDrive is like some backup software to the cloud. Or it can hit something that's in use or something like that, and it'll throw an error. But I can also, by the way, if I want, I can just say limit. And this is very common practice in SQL to just, before you do that, you just always set a limit, Okay. Let's keep going with some, let me see. Let's get creative here. I showed you deep. I showed you some of these. Let's see some dates. So, okay, so this is what I have. Do I have this open here? Go file test. I created just a file of. All right, so here's some files. Most of these are just filled with stuff from short stories and dummy text in here. And another folder in here just to do some file stuff to be able to test between different extensions. Okay, so I just did, I grabbed a few. Here's a file text too. In the output of this, the select, I have a truncation going on here because obviously it can get kind of crazy if I include the file text of any file. Some of these can be very, very long, and that's not really desirable to print here on the screen. I should do that probably with file names as well. I have not, but it's easy to do. And if something is binary, I also trap for that. It would be nice. It doesn't exist currently in the out-of-the-box query function. I mentioned there's only about four things in there, which is name, date, size, that kind of thing. It doesn't have something like binary. It would be nice if it did, but it doesn't. So I have to detect that because I don't want to barf binary stuff all over the screen. I also deline, and I usually trim all also just for here because it can start to wrap around and get pretty ugly on the screen. The output of this query, though, does exist. It's saved to a result, and that does contain the complete untruncated, unprocessed version of the file text. But just for the purpose of displaying it on the screen, some of this truncation is done just to make it more manageable. So what we did, by the way, to highlight, is we just got all the files in that one directory. And you know what? I'm not even doing it. I'll add it, though. Here, let's do it deep. And I can put deep anywhere on the from. It doesn't really matter. So we have 17. Did I say from? I can't see my. Hang on a second. I want file tests, otherwise it's going to take a while. Right, file tests. Just check. Okay. Okay, so that's my file test directory. So that was deep, and you know what? Let me show you, instead of file, I'll show you a name. name should be the entire thing, right? So now you can see these are all the files in here. That's the date. So let me go to 2020. Have anything that should... So maybe this will purge that out. So there was a file in here that was from 2019, and so I just changed the date just to show that it, you know, it runs that in that where clause. Obviously, it's that is filtering out anything that's not meeting that date window. Not really that fancy, but it's worth showing. I think we already took a look at the file text stuff. So here are some files in here from a short story, Memento, which was the basis for the movie Memento. And so I just grabbed, you know, a name that was one of the characters in the story. So this is the output from that. As you can see, it did a text search. Let's see. I think you guys get the idea for this already. So here's size. This is just using size, which obviously is a digit. So size equals 500, 400. It went from 8 to 6. 300, you get the idea. All right, yeah, let's do some, we didn't get to any of the braces or anything. So let's take a look at, this is using braces. So when you use a brace, it takes a term and it ORs all these terms. So this is just going to find anything with the name, you know, that meets the name apple, banana, or cherry, HTML, or HTM. And that's what came back in here. Let's just see here. Apple, banana, or cherry. And I guess that's got to be in folder 2 then, right? Yeah, it's in folder 2. It's the only thing that has apple, banana, or cherry in it. You get the idea. One more thing. Let's just do some wildcards and stuff. Let's just find anything that has apple. Let's do... That should work, right? So that just found, we already did an example of this brace, anything that's text, HTML, or HTM. Because of the way search works, right? I mean, this is a lot of things. You have to use it's greedy, so you have to use HTML before you use HTM. Otherwise, you'll never get to HTM because it's going to match HTM before HTML. This is picking up anything before Apple and anything there. Let's use something with a brace. Let's go to a brace. So here is a brace, which just means that it's going to create a bit set, basically. A brace is, no, not a brace, a bracket is for any character. And you can use, this is like in parse, where you can use character sets. So I'm looking for anything that ends in apple with either a 2 or a 3. So you can see up here we have both 0 and then, well, or nothing, then 1, 2, 3. Let's do 2 or 3. So now I only got results that have 2 or 3 in them. And I can also say not anything that doesn't have 2 or 3 in it as a character other than 2 or 3 in it. And it's going to give me apple 1 over here. So that is the token or the symbol for knotting the bracket. I can also do some other things. There's an in clause, and in the future I will add something where you can say file in, and you can just substitute anything in here. I'll allow variables here, so you can just pull in whatever file list you want. It would also be good to be able to do another select query here, so you could find the results of another query. Here's an example. Selecting everything from these tests in both, there's only 2 directories here. And I'm looking for the file, which is just the file name in any one of these 3 things. So we get back and we got apple, banana, and cherry. These are in multiple directories. I mean, you can start to go kind of crazy from here and do all kinds of fun stuff. But these are just some of the tools that I wanted to demonstrate. There's a lot you can get done here. In particular, I would like to add something where instead of just selecting, I can't do it right now, but I can say select into, and then I can, what that will do is take this entire query result, and then I can push it into something else. So select into, and I can say, publish directory in some. So I can take, and what this is an example of perhaps adding clauses if you wanted, that would let you accomplish other extensions of SQL. So basically I'm leveraging SQL, I'm getting the results, and then I would be pushing these results into, for example, something like build markup. And in these, publish is a little bit different. I can have publish basically execute these files, and in my web files there could be a bunch of markup in there that has the variable for interpolation that would come from the data of this. So basically you're using this query with its results to then publish into the template files that exist within this directory. So that's something that is very straightforward to add to this as an example. And you can, and that's what I was getting at with this. So this is SQL, right? And it's just sort of a SQL type of, a series of simple clause-like English kind of like clauses that allow you to sort of format and process information in a certain way. But you can add your own clauses to be able to extend this. And you're just using, in this case, the model of the way this executes, and to be able to then do something like create a publishing, like a static site generator from this, or maybe you have something completely different. Maybe what you want to do is, instead of, and you say, you know what, I don't really care about file munging, Ed. I already have 20 scripts that I use all the time for file munging. I don't need that here. But I could use this same dialect, for example, and not file munge with it. I can just use the way that these clauses are executed and the logic there, and I'll put my own keywords in there and my own values in those clauses, and add my own functions if I want. And from that, I can then use that to, for example, maybe it was Chris. Maybe Chris created a curl wrapper where you can invoke curl and be able to get web pages from. I could use these SQL clauses and continue to use SQL or some modified version of SQL as a wrapper to call curl and to get web pages and recursively, or webget for that matter, and recursively get web pages or content from those external applications. And it has nothing to do with the file munging here. It's just an example of using a syntax, which is purely an abstraction layer, and applying it, as I'm doing here for file munging kind of operations, to apply it to other domains. It can be a wrapper for curl. It can be a wrapper for webget. It could be any number of opportunities that you might have to create things that simply are easier to interact with because you have a a simple dialect model. A model that will incorporate the way something is parsed and interpreted, and error handling, and to some extent maybe even managing the state of it. I intend to use this. What we're looking at here is a very simple, straightforward execution, really a translation of these symbols in a query, and it goes through based on clauses that have been defined in the dialect, translates those into Ren-c, like a list comprehension, and then just executes and spits out the results. But I can change that around, and I can, instead of just using it in this very plain sense, I can create my own REPL if I want. A read eval print loop, and it would be nice within Ren-c, in my view, if we could I could automatically create my own shell. So I could use this, query shell, for example. Hit that, it's going to say, I don't know what you're talking about, and then be able to go into my own shell that is a REPL for this, where I can do whatever exploratory file munging I need, for example, and then be able to export that and come back to this shell, and it's no longer a REPL. It's it's the command line here for Ren-c, and continue my programming, and maybe even pull in the data that I had in that other shell. And if I had another dialect, I could create a REPL for that and a command line for that, and be able to go over to that and interact with that, and maybe even tie those together if I want. So that's kind of where I'm headed with that. And to be overly heavy-handed with my message here, it's not about SQL really. It's really about coming up with a pretty standard, friendly dialect model that you can do whatever you want with. This just happens to be file munging because it's nice to do that on Windows, and there are many other utilities that will do this. They all mostly are difficult, or they look like, here's an example of what one looks like when I put here's an example of the kind of utility you get when you're trying to match and rename and do file munging. There are just way too many controls to do a good job at it, and something like SQL hides a lot of this complexity. And about 80% of people know, of developers for sure, know basic SQL. It's quite easy, and I would say it's easier to learn and quicker to learn than HTML is. You can learn the basics of SQL, I would say, in about a half an hour and be very productive with it. So, but the point here is that this is a model for creating languages. It doesn't have to be SQL, and it doesn't have to be file munging. It's the pattern and the model that you can then leverage to apply towards your own domains. And just like SQL has column functions that help fill in the gaps for the functionality that you don't get, and there are other customizations that are platform specific in SQL, depending on the DBMS, that allow you to achieve a little bit more because the SQL language itself is a simple abstraction. And I mentioned also that parse is also a dialect, and it's not it's not general purpose. It's quite specific in what it does, and therefore it has some gaps in it as well. And what does it do? It allows you to inject your own Ren-c, your own Rebol in there, and to be able to work and fill in those gaps. It's quite good. You should be able to do the same thing with this model, where you can take and customize the dialect to your desire. It's not perfect. It's a dialect. It's limited. But you should be able to pull in your own Ren-c to this, or other dialects if necessary, to be able to pull in and to be able to execute those embedded within this, in order to fill in and extend the dialect that and the range of functionality that you're trying to achieve with your dialect. So let me go back to my deck and just talk a little bit about the next version of this. So I have some brace expansions. I have brackets. I have basic wildcards and things like that, and they work pretty well. None of them are as powerful as parse itself, though, and I am going to try to also allow in this model to, especially in the select line, there are a lot of column functions which are quite useful in SQL, and it would be nice to support many of them, and I will probably do that. Maybe not all of them, but some of them are quite important, like count, for example. When we did that grep example, the simple grep really, we got all of the instances or recurrences of that string in our result set, which is fine, but sometimes you don't really need that. Maybe you just want the count. Give me, tell me the count of that instead of printing out that thing out for every row. So that's an example of a column function. I would do something like that. But I would also like to be able, allow developers to use their own Rebol defined functions in there. So that means this is like embedding in parse, right? Embedding Rebol in parse. So I would like to be able to use a parse rule or some limited version of a parse rule or something that allows more Rebol-ish manipulation of the data in the select statement so that you don't have to, not all of us are experts in SQL and know all the different, there's like 100 probably column functions that you can apply in a select clause in SQL. I don't know them all, and I don't think I would like to nest all that many. It would be more attractive to me. I mean, it would be nice for people who are SQL people and not Ren-c or Rebol people to be able to use this and be able to just, file munge using this Ren-c and not even necessarily be experts in Ren-c. It would be another access point into Ren-c to be able to use a utility like this. I would want people to be able to develop their the Ren-c developers to be able to not have to learn all of the SQL that a SQL guru might know or a SQL admin might know. It would be nice to also be able to just inject your own Rebol into this to be able to apply all the functions that we are very well familiar with and the syntax and the language structure. That would be a very powerful option for us to be able to use this without having to learn, too much SQL, right? Another thing, while I have anding working quite well, and we can add as many things in where as we want into that clause, which is great, I have not yet implemented the or the not logic yet, so I just haven't gotten to that yet. And I just showed you an example of select into. Select into, instead of just taking, in SQL, what it means is you're selecting and getting the results, and you're going to inject them into a new table. So select into, in my book, my file munging world is more like that publish, I'm going to call it like a, populate or publish clause or something like that. So it would be like publish into, and that would take the data set and push them into, for example, a template directory, and then all of your content from the rows of data that you have in your result set will get pushed into these templates. That's an important one for me because I want to use that a lot more for some of the work responsibilities I have. And I already mentioned column functions. Those are just important things to add to massage some of the data that's coming out in that select or that output. Some upgrades that I also am planning on, and I have some of these actually already working in my other version, but keyword synonyms. I didn't show you any of this, but there's a bunch of them. I mean, they're not really that important, but I don't really have to say select, and what I'd like to have everything do is be as short as possible, right? So I could, I don't even have to say, I can just say. So I have synonyms for things, and for between. Do I have a between in here? There are some abbreviations here, but what I'm proposing, and I'd be perfectly happy to add. I want to add these. I have these basically working already. Is keyword synonyms. So I can just define these on the fly if I want. So, I mean, I can't change what these, unless I change code, I can't change what these are actual values, which are not changeable. They either exist or they don't in the data. But I can change my keywords. I can add keywords. I could also say, I want to be able to say, like, my directory, and what that would do, right, is that's just a variable, right? So that's going to pull in, and I could say, if I have a longer script, I can say my directory equals right. So I declare something up front earlier, and then later on I can inject it in multiple places if I want, or a single place, whatever I want. Or particularly if I'm in a REPL situation where this is really just executing a single line of dialect. But if I'm in an interpreter or a command line, being able to define some variables and then be able to apply them however I want. And for example, I could just say where date between. I could also say where date, and I could just say, I don't know, 1, 8, 2, something like that. And maybe, I don't really know exactly what. I don't use this notation yet. I use something else completely in my other dialect that does this, but you get the idea. So the ability to create and add variables that get substituted, the ability to change and add keywords. Ignore case. That's one that I have to work on a little bit. I just haven't really gotten to it. I'm trying to remember what. I think the Unix tools, they use something called ignore case, and I'd rather not. I'm not sure. I'm not sure how I want to handle this, but I could just, somewhere in here, I would have to say something like, and then everything becomes, case sensitive, right? But I need to figure that one out. And then clause order agnostic. That means you can put whatever clause in whatever order you like. Maybe, and again, this also makes a little bit more sense if you're in a dynamic interpreter, at a REPL command line. You can enter some things in, and then, or even save an entire clause to a substitution variable, and then be able to apply that later on. It just adds for a more exploratory, piecemeal approach to a command line, where, like, I can start a query and it's a fragment and it doesn't have all the information it needs, and it'll just say, add the, you didn't add a select clause, add the select clause, and it just reminds you which clauses are outstanding. So those are some of the things that I have on my plate. I've been looking at. Do I have anything else? That's about all I have to share for now. Anyway, you guys get a sense of what I'm going for, I think. I've been very repetitive over the fact that I think it's the model that's more important than the actual feature of SQL for file munging. I just think there's a nice opportunity to create a kind of structure that can serve as a prototype for anyone, or a starting point for anyone who would be interested in creating a keyword-based domain-specific language or dialect. Now, a keyword dialect is not does not represent all of dialecting. You can create very elaborate dialects that do all kinds of things. Maybe something that is like PostScript. That this would kind of dialect would not be a good fit for that. This would be a good dialect for a home automation dialect, like turn the lights on at 9 p.m. or buy, Microsoft stock at $100 or like very basic, very basic kind of, or they can be quite elaborate. But I mean, that is of the variety of a keyword or command style dialect, as opposed to something that is very into the very specialized domain of, it could be binary or whatever. This would not be great for that. This is really a language, a dialect model that is similar to SQL or similar to Rebol. And that's sort of that's the limitation of it. But anyway, that's the opportunity that I see and that I'm shooting for here. So if anyone has any questions.
Yeah, I mean, to your point about it being important to think about how people are implementing these dialects and what kind of infrastructure is being offered. There hasn't been much. I was looking at other languages that have what are called parser combinators, and this is just sort of when they do parse, they build these functions that take some of the input, and then they give you back a function that will operate on the part of the input that it gave, and then you just keep building up these functions to process the input. And many of them do it in user mode, right? Like Clojure or Rust or Haskell. They don't have some hard-coded, in the system, unchangeable concept of parse. They build it up in user mode. And so I was thinking, like, how would you do that if you were just starting from scratch? If you had Rebol, but you knew kind of an idea for parse and you wanted to implement parse, how would you do it? How would you get started on that question, and how would you get a result out of it that looked like parse, that hopefully you'd be able to tweak and extend and maybe add something like the collect keyword to be able to collect and keep, but also to be able to go with the rollback or whatever. Like, how would a user write that if they're not in C? Because if you look in the C code parse, it's very complex, and it's very handwritten to do exactly what it does and not much else. And it doesn't have a lot of internal elegant cascading structure to it. And as a consequence, it's very hard to change, because it's hard to get a good error out of it, because it's so fixated on, am I in sub mode, set a bit over here, thing like that. So if we can ever get any examples like this of somebody who sits down in user mode and is writing a dialect and looking to build something, like you talk about error handling, you can talk about sort of what's the philosophy. I mean, I think that getting people into a universe where they have these things answered, and you don't know whether to use at to mean get variable or get word, right?
Yeah.
You're like, I don't know. I think it's good that we have the at words now, because we have like another word type, because we do run, we need these things. Like in parse, there's a difference between referencing a word that holds a block because you want to use that block as a rule, versus matching that literal block. And so I think that is an example, for instance, where we would want to use the at words, that if you use an at word, that means whatever this variable holds, match that in the input. If it's a block and if the variable holds a block, and I use at var and match the block. So if we set, you set some sort of conventions, and you get people into a universe where people go like, yeah, we all kind of agree this is like a good way to do it, then maybe there's a compass. But if there's not, then this stuff just starts to look like really confusing, and you got to wonder, where you are, and is it causing more trouble than it's helping? So yeah, I definitely think that having this as an example where we do answer those questions, like if you have a dialect that's like this, that's sequel-like, when do we use the quoted words? When do we use the issue? When do we use issues? When do we use that words? So yes, in terms of finding what the model is and the state.
Well, for me, I think it really depends on the dialect. So, I mean, I don't know that there is real. So my approach to this stuff, Brian, is very lax, right? So all I'm doing, what you're seeing here is these are just symbols. They don't overwrite or redefine anything. Nothing in the system, like they don't even need to be protected in any way. I think last time we said, oh, we want to keep these as, as lit words or something. I'm like, it doesn't really matter to me. So what I do here, for example, even though I switch it to be lit words, this is purely a string, a block of symbols, and it's getting translated into Rebel code. Nothing in here ever overwrites anything in the system. It's just a string of symbols, like Morse code or something, So that's a different approach than having this stuff in here actually be like computable or a set of instructions. These aren't instructions yet. This is just a pattern of symbols,
You're saying you're not using binding,
Yeah.
So what they look up to doesn't matter to you, but it will matter.
Yeah. So for example, if I said
at to get the variable, if
Yeah.
you're going to get a variable, you have to know what it holds. And if you have a group and you're going to run code in it, that has to be bound.
Yeah, I think you're right. If you want this stuff to be loadable and then this stuff to actually be Rebel code or instructions, then it has to obey those laws. Yeah, this stuff, even like select asterisk is what is it? It's multiplication, right? So, I can't possibly use it. There's way too many things that I'd have to work around if I were to use any of this as code. This is purely just a string of symbols that I'm going to use to match against a dialect and translate into Ren-c code. So.
Yeah, and there are philosophical questions to answer there, like, do we find it, when we have this opportunity to have the different data types, to have issue, to have tag, do we want to inherit things like using asterisk that's a word? Do we want to be, should it be a tag which is left less than sign star greater than to pull it out of the realm of words if it's going to be a wild card or something like that. But
what was that?
The idea of the fields being when you're naming a field, not having those be different when there's no group around them, like there's not like a block where you say select, open a block, word, close block from. I think there's a level of laissez-faire that is probably bad. I would come out and say that it is probably bad to just say select file name from and be looking for the from when there's like multiple keywords, like not just from, but you're talking about reordering and stuff like that. I feel like there should probably be, you should probably put that, the fields that you're selecting inside a block or something. And if you don't put them inside a block, then I think.
And I think this also gets us to, so one of my goals here also is I really wanted like a new entry point into Ren-c. Like I wanted someone who really basically doesn't know anything about Ren-c to be able to say, well, I don't know Ren-c or this crazy Rebel stuff, but I do need a file munging utility, and I know SQL, and this is a pretty low barrier to entry to get into. So I did not want to make, to the extent possible, really, my goal is really not to make this too Rebel-like, because I feel like then you're fitting the problem to meet your solution instead of like what I want, which is to allow anyone who knows SQL to pretty much be able to pick this up and in 5 minutes be like, oh, I get it. There's a couple little nuances, like, I got to use this, percent symbol for files, and and I got to use, like, I don't have to put a semicolon at the end of my expressions, and there are a few other things in there also. But I really want to try to make this as close to just normal basic SQL as possible. Now, if we're looking at using query or something like this as an example of an internal embedded DSL within Ren-c, yeah, maybe you want to make this much closer to something that is to Ren-c. But my original goals here was to try to come as much as possible closer to the expertise level of someone who just knows SQL, So that's kind of where I was coming with that. And I didn't really think through all the things that maybe you would want to do and try to set up if you had Ren-c developers and you want to say, well, this is the right way to set up a dialect, and these are our conventions. No, I was really trying to just let someone who barely knew a damn thing about Rebol and has no interest really, but to be able to use this type of syntax and to achieve something with minimal kind of learning curve.
Yeah, that's another point that I kind of thought, looking at the patterns where you embed the language into the string has that advantage that it's compact. When you're talking about Rebol, it's words separated by spaces or tokens separated by spaces, and then you realize that spaces eventually they do add up, So what do you mean? When you can put a pattern into a string with the curly braces and the commas and everything's all crunched right together, there is an advantage there that when you think about it being broken apart, you go, so maybe we should be wondering a bit about when and where.
Sorry, what's the what's the concern there? Just
not concern. I was just saying that when I look at it, I think about like that it doesn't have now you've got to process this string because you're not taking advantage of the structure, and that if you were writing like a parse itself doesn't have little wildcard dialects inside it. Maybe it should. I don't know. To let you more succinctly express, glob style patterns. And it's just sort of a trade-off to look at a dialect that's designed to deliberately not go the route of the words separated by spaces, which means it's harder to abstract. I mean, how might you put in a variable, that, if one of your alternates is a variable, how do you put it in there? Or do you start putting dollar signs and then have a name, and then you have to look up, where do you look up that escape name, right? So these languages, because they're not broken out and they're using the strings as a pattern language, you're also having to do your own brace matching, right? You're not getting the parentheses and the blocks. So it's kind of a question of how to handle or how to model, or what our mental model is when we run up against the sort of obvious fact that those are briefer, they're denser, and they could be good shorthands. How do we have the full version? How far do we go before we stop? Like I suggest the dollar signs to escape variables is too far, in my opinion, especially since you don't have the binding to work on your favor. So maybe saying that those are shorthands for something that does expand, where you can do those substitutions and do compose or whatever, and not have to match your braces. It's just something I saw go by. You sit there and you go like, darn it, that does seem very convenient. If it didn't seem convenient, then we'd be fine, because we just do things the way we do it, with large expanded blocks and spaces and vertical bars, everywhere. But then you think about how many lines that would be compared to these packed string mini languages.
Yeah, yeah, and that's what's nice about these little little languages in Unix, right? They're very terse and succinct usually, but to a fault, quite frequently to even grep, and so. But I also wanted to try to make this like a one-liner, like within one line, you can pretty much express something and get all these results back, and so it was important to me to also try to respect keeping it compact and something that is not a whole hell of a lot of typing. So
yeah, no, it's great. I mean, I would I'd use it. I think definitely having starting the best. If you ask me, you're certainly at the point where having a Travis, having some tests. You're starting to set up your test files. Even just testing it to make sure it doesn't crash. Make sure it.
This is one of those. You live this, but I mean, I don't to the same extent. But it's a combinatorial kind of nightmare. All this stuff.
Yeah, but just the sooner the better to have it. So yeah, I mean, if I could use it, I'd use it, and then if I go, it's not working, patch it and go. It's probably more fun for me, and may even be faster to fix a bug in it than it is to read the pages to get the query that I'm looking for. To do it with find and grep, and if it's complicated, I mean, the only thing I know memorized to use any of those tools that I don't have to go look up on a web page, which I usually look up I phrase the English. How do you search subdirectories with partial file names, but only the read-only ones or something? I'll type that in, and I'll find someone's already written it, and then I'll try it. But if it's not like that, then I have to find something that's kind of close and then try to change it.
Sure.
I had to do some awk. This was on another project I was doing on the other day, and the person had used. I guess it was awk, and to do some processing of a file to bundle it together, to glue several files together and trim some stuff out of it, and I couldn't believe the crazy nightmare of trying to change that to look for a beginning pattern, ending pattern, and I was looking for a beginning if-def and ending if-def, and wanting to take the code between it out. Something just trivial like that. And I could have done that in a minute using anything else, but this person had used awk, and so to patch what they had, I had to patch it in awk. And I was like, this is a nightmare.
Yeah. I've looked at a whole bunch of those languages. Awk, said. There's so many, and
they operate on a very base sort of level of what the model of the engine, and how very, very micro optimizy about how many characters are in the pipe and then so they process large numbers of files very quickly because of the crazed model. But even still, I mean, we could do some dialects that capture these models and build something that dynamically runs and does that.
How has anybody used SQL, like in the kind of traditional sense, the traditional grammar? Have they used SQL in this domain before? Like, do you have any models?
Sure.
There's open source projects.
How would you? Sorry, just a little follow up on that. It's like how would you go about if you could only do this in SQL? Could you? How far could you get just using SQL syntax and loading that in and processing like your loaded symbols? Like not relying on the symbols that Ren-c has or Rebol has, but like the symbols that you would find in
you would run into some problems. I mean, you would have to massage the syntax. I mean, it's not that far, and it's doable. But there's quite a few pieces of standard syntax that wouldn't be supported. So, like, most strings would have to be like this, and you have to end your statements with your expressions with a semicolon, and and there's lots of parentheses and things like that. So, these are minor things. You can scrub those things, but you would be doing some scrubbing.
Because where I'm kind of going with that is if you're looking to kind of present this to people that aren't already kind of like interested in Rebol, as you say, then that might be a way in if you have this as an alternate syntax where it's like you can do a lot of this stuff with SQL, and also you can do it like direct with this. So it would be a sort of a different entry point for, again, people that know SQL but don't know Rebol. And that way you can kind of at some point do a map. Like you would do it this way in the SQL syntax. Here's how you do it in the Rebol syntax. And you kind of have a little kind of extra versatility with that. That's just a thought.
I'm not sure if I follow entirely, but so SQL, the syntax that exists outside of what I'm showing here, I mean, it can vary a little bit from platform to platform. There are lots of software platforms that will implement SQL for its own, analytics platforms, for example, will often use it for their own query language as a form of search. But SQL, as it's in a database, would not translate well over to this domain because it just doesn't work like this. So,
because like a SQL parser is not that, it's not that complicated that it wouldn't be difficult to write. It's just like how far could you get, like limiting yourself to that so that would be like an entry point, or even just an alternative.
So also my point, which I think I find SQL to be quite constrained, and I think that more later generation things like LINQ, L-I-N-Q, if you know LINQ, and there might be one or two others, they've started to get away from some of the rigidity of SQL and to make them more composable. And I think that adds a lot of power, and it kind of corrects for some of the things in SQL which are very limiting. And I think if you stick to the more traditional SQL, my belief, I mean, I can reevaluate this and think about it for a while and see what my thoughts really are, but my reaction to this would be that it would be hard, as I've said, I think it's the model that's more important than what you're doing with SQL, the syntax itself. Like, in other words, having like clauses and being able to evaluate clauses in a specific kind of order, whatever the contents may be of those clauses. I think that's a more important model and a more solid foundation as a basis for, or prototype for dialects than SQL and its syntax itself. I mean, SQL is, I'm using the syntax because it's well known and it's very familiar, which is great. But I think if you take traditional SQL and its syntax, that it will not be used like extendable. It will not be easily.
How is it
composable.
How is it kind of stretched by people that have worked in this domain before?
Stretched?
How did they represent some of the things that aren't kind of database like? So if you're using it for file munging, how do they represent files, and how do they represent some of the other things in this domain?
I would have to take a look. I mean, I have a number of. I have so many. It's almost crazy. The number of. Here, can I escape? Yeah. So if I open and look at my SQL folder here. So here's some for tool comparison. So these are all, for example, tools, and there's a few, there's probably 50 at least versions of SQL across various domains. Everyone, I mean, it's a very universal, the closest we can almost get to a universal syntax. So that actually does something more than a markup language, right? So it's used all over the place, and your answer is going to be a little bit different depending on what you're looking at. So I've seen versions of SQL that are implemented in JavaScript, for example. Actually, I was trying to find it in my. I couldn't find it in my bookmarks. I wanted to include just in the slide deck that I was hoping to put together.
Yeah, I think I'm familiar with like Ruby on Rails using maps to.
Using what?
You all right there, Brian?
Yeah, it's Thunder.
Oh goodness. Using maps to kind of represent the different segments of like a query.
Yeah, but that's actually using that's sort of like an ORM, I think, an object relational mapper, in order to get Ruby code or into a database. It's actually going to be talking to a database, and you'll notice almost everything that I'm doing here. I know it's a little confusing, but I'm not thinking about databases at all. That's very well charted territory. I mean, certainly you could write a query or something like this, and one of the things could be where you send it off, that string off to a database to actually process and then get it back. That's you would be bypassing this whole interpretation altogether, right? Because you're using the database engine. Really, you might massage this into whatever the formal SQL output should be, but then it just goes over to the database and then you get back a table of data, right? So all of this, and I'm trying to get away from the SQL being tied to the domain of databases, and I'm trying to different syntaxes with it. And I think you can take that further. Like, you could use a SQL syntax for almost anything that is of a large extent a CRUD style, create, update, delete style model of programming. So a wrapper, for example, like for cron or for curl or for webget or for a number of utilities, and those are mostly things that you're querying anyway. So that's kind of my interest. And again, not exactly so much the syntax of SQL.
No, the semantic.
The model of how you put things into short, actionable clauses. They're not that far from functional style programming. That's why I think the last time I was mentioning list comprehensions. You're basically just sort of translating all this into a form of list comprehension. And so it's not so much the syntax itself. And I know it's very deceptive because everything I'm showing you is about how you use SQL to mine for files and stuff, which is true. That's what I'm showing. But I'm going to try to get beyond that at some point, where we're not discussing the actual SQL syntax, but rather the model of using clauses that do specific things. Like, one is output, one is filter, and one is declaring a data source. And just like the way parse is quite specific, you fill in the gaps and the other types of functionalities you might want with the ability to sprinkle in Rebel code in there. Kind of like that, where you have a certain model that you can then fill with whatever the pattern, the syntax pattern is you want, as long as it's parsable in Rebel values in some way, and then to be able to execute Rebel code, in parentheses or in some notation embedded within those expressions, if you like.
I think you said something.
I think you're asking something, Chris, and I'm steering you in another direction. But I promise I will try to.
Yeah, it's not. It's really just like it's kind of like the. It's not a syntax question. The syntax is only kind of because an entry point for somebody that's more familiar with SQL is like, how do you. You're suddenly using this kind of alien syntax. It's like, does the semantic model kind of still work if you were using the SQL syntax? I'm trying to think of a better way to put it, but it's just like you have that. So. Yeah.
Well, Chris, let me interject quickly here. Chris, if you want to see something that's like a good example of seeing, SQL applied to a lot of different domains, look up OS query and look up the. You can go to they have a list of all their schemas of how they've done schemas for the table of processes on your computer. They have schemas for the number of browser extensions you have in Firefox, and they have a model by which people add new data sources. If you can find the schemas,
It's quite heavy-handed, but though.
Well, I think it's kind of this answer. I think this will answer some of what you're thinking, and also OS Query. You can just download a binary and run it on Mac, and I think you would find it to be kind of an enlightening experience. I did, and I built it actually on Linux, and helped them build under the latest Ubuntu or whatever, because they weren't doing that. So I patched some stuff, but if you just look at all these tables, and check it out, like you really, learning this is better than knowing all the weird, stupid commands on your computer. Just download the package, and you have access to all this.
The Rebel brain question is like how big is the executable?
How big is this? It's big. This is a big executable, because what they do is they actually link. They have, when you build it, it's actually taking all the different programs, and like building the like the Red Hat package manager. If you have you wouldn't have that on Mac, but yeah, it's a big thing. So our angle is programmability and scriptability at a level that this wouldn't have.
For sure, yeah. I completely get why the benefits to using Rebel syntax to do this, because you have the moldability of Rebel to do that.
The other thing I was going to say, Ed, is I think you kind of guided towards what the value offering is when you said you be in a shell mode, and it could tell you like, hey, what are the clauses that you haven't given, or what's maybe like if you've typed something. What are still options? What's been ruled out?
Yeah, maybe next time I can show my other version was really based around that, building a command line or read about print loop, which does exactly that. It just, if you supply one little piece or define something, and it's it's like a small finite state machine, and it says, well, okay, here's you owe, this is an incomplete expression, and it prompts you for the remaining. And it just keeps going, and then as soon as even if you have a fragment, you can execute that, and you can just keep adding clauses to it. Like we were showing the where condition. You can keep anding things if you want, and refining your So it's an interactive way of stepping through SQL expressions for file mending.
And I think that by explaining that helps to sort of differentiate and explain, like, well, why isn't this a typical row, what are you offering that parse wouldn't offer, right? Or what are you offering that a railroad diagram type thing isn't offering? You're saying like, okay, well, there's a model, there's a state machine, and then there's some, what are the facilities that it's giving you? You can, to keep track of what clauses you've given so far, to let you add another one, to rule out a branch, like, oh, if you're going to do this, you can't use that. And to have that logic, and to say that it's driven by these keywords and clauses, and to sort out the idea of what the different parts of speech mean, which I do still think is a very important thing to do. All right. We should thank you, Ed, for presenting there. Appreciate it. I wanted to mention a couple things, if we have some time, just to throw a couple thoughts out. One, it's good. Okay, like I said, I sat down the other day looking at parser combinators, Enclosure and Rust, and all these people who are doing parser combinators. But to me, the most interesting is Haskell, because they've got such big, deep ones like megaparsec. So the thought I had was just like, I want parse redevelopment to start thinking about because honestly, the parse code base is bad. I mean, I'll just call the R3 alpha code base bad, in that it was not written it's organic. I mean, the evolution is obvious. It's obvious it evolved over time, got another feature, got added. There was a bunch of stuff that was not very rigorous in the beginning about, lifetimes of things in garbage collector. Most of that's worked out. But going and tackling it with a fresh implementation like Red got the opportunity to do could be very interesting. I thought about it, but I think it would have to be done through user mode. So that's one little thought I had, which is maybe other people, maybe Chris if you've ever given thought to the idea of how, let's say parse didn't exist, but you had an idea for it. And
you seem like, I mean, I haven't really demonstrated, but parse machine, it's kind of like, one of the reasons I'm doing it is just like a different way of approaching like a whole parse project, and it just doesn't, I don't know, the way that people have gone about using parse to kind of solve some problems, just it's not versatile, it doesn't really work. So I've kind of been thinking about more like the state machine style, like stripping it back to kind of as basic like parse blocks as you can possibly do.
Good. So that's along the lines of, maybe, and it might benefit you as well if you have not ever sat down with these parser combinators in other languages like a Haskell combinator. Some of that stuff is pretty neat.
I took a little look at it after you posted it. It's interesting.
I haven't had a chance to really dig into it too much. I've just sketched out my thoughts and what I want to sort of get to. But I mean, it's important to me to try to use parse to be able to apply different rules at different steps of a parse. So that's almost sort of a blend between parse, the way it works today, and a finite state machine, because you're wherever you're only going to advance when you hit like the rules for each step. Let's say you had a block, for example. At each step of the block, it can have its own set of rules. So it's like a context-dependent parse, because it's going to apply rules in order to advance at each stage. And
HTML now is defined as a state machine. Like it's the specification is, these are the states that you are in when you're parsing HTML. There's no point of failure. Any blob of bytes is a valid HTML file, and it's just like it just moves through different. That's how it's defined. It's not defined as your head tag here, and it's all states.
Yeah, so I want to be able to better manage, like if you think of a directed graph of some kind, like you have point A, point B, point C, point D, and then maybe you complete it. But to be able, at each stage, to be able to have its set of rules that it needs to be able to advance, and that changes from every step. It sounds like someone's eating Cheetos or something.
Graham's avatar is talking and chattering away down there.
But he's on mute.
Well, that doesn't
echoes whoever's talking.
That someone's talking, or he's talking, or he's watching TV, or whatever. But
no, I'm not on mute. I'm not on mute. Actually, I was just going back to Ed's talk. I mean, I think there's something called extended file attributes in NT. Is that right? And you can actually write data to the actual file name, which is hidden, and which is carried with the file itself. You're aware of
Sure, Apple has its own versions of those things. It depends on the file system, yeah. But I'm just relying on what comes back from the query function of Rebol. So,
right.
I mean, if you open a port and do fancier stuff than that, yeah, you can tap into more information, I'm sure.
So the other thing I was thinking
actually
about,
have multiple streams of data in one file, so it's like a zip file almost, like it can pack several streams together. But then when you copy the file into a non-NTFS file system, you will only get the primary stream, which means that you can use the other streams as, some kind of cached thumbnails or something that you regenerate elsewhere. I don't know. I have some of this knowledge like in the back of my brain somewhere. Like I know these things to be true because I learned them.
Because I store usernames with my Synapse. I store it actually in the file name itself. It's hidden unless you actually try and look for it. So when somebody opens up the application, their username pops up in the user password challenge, because it's actually embedded in the actual .exe file. So the other thing I was thinking about was it would be nice to say select all these PNGs they've got that show a boat in them. So you should be able to take the image, send it off to computer vision, and get a result
I've done
back.
that.
Hey?
So I have about 100,000 images on my one of the main websites that I manage.
Yeah.
And they didn't have any accessibility, which meant, people using assistance devices or sight impaired. If they were using audio or whatever, there are a number of different programs that they use in order to navigate the web, like Lynx or whatever. They're minimal browsers. But there weren't descriptors for the images, which exposes my company to legal challenges, and we have been given complaints. So there's no formal legislation in the United States yet, but it's
the old field, is it? The old field in HTML for images. Yeah.
So I just took all the images and I fed them using Rebol and fed them through Microsoft's Vision API and they weren't perfect, but for about $75 and in about 20 hours worth of running it through there, or maybe it was 2 or 3 days, I got descriptors back, and at least right away we were able to put crappy descriptors out there until we could have humans validate them. But yeah, I've used it before.
Well, that's pretty impressive, isn't it?
Well, it's no different than just posting something to it's surprisingly easier than you think. I mean, it's the API that's doing all the work.
Oh yeah.
You would think if you were vision impaired, you would have the ability to run your images through something that would recognize it. So if you ever saw one that wasn't, you'd be like, "It's just image." It's like, well, describe it to me.
So these new password challenges that say select those images that show a car or whatever it is.
Yeah,
I used that API about 2 years
ago. I will never be able to figure these out.
Yeah. So sometimes the descriptions that come back were wildly off, though. Like there'd be a bridge over a river or something, and it would be like a family of small ducks.
Maybe they were just really small, and you just didn't see them, but it did.
Well, I'd like to go through all my Google Photos and say select all images of me between the ages of N and N.
Yeah.
So I want to mention another thing, which is how many people read the dynamic let post?
I did.
So I think it may be happening. So just news of what I've been working on something lately. Just trying to keep code under control, trying to keep things small. Involves constantly going back to it, and every time you reach a threshold and you go, if we do this, this is going to create this many more objects, or going to cross some threshold. And so you guys kind of go, all right, is there some way we can go back and not do that? And so I've been doing a lot of that, which is to say, how do we grow features without expanding the data structures too much? The let thing is a big, it's a tough one. I think it may be somewhere where we go ahead and say, like, you either pre-declare your locals in your function, or you pay for the idea of potentially having a let each time you're going through a loop. If you put the let in the loop, you're doing a allocation each time through the loop, and you're going to be paying for a certain virtualization to pick up that. So it's sort of a thought point that I really think that there's a limited sense in which I think it makes. I don't know how much it makes sense to be going for super high performance. It makes more sense to be going for super high expressibility. I'm happy to put off the white space explaining that and what's going on over there.
This is like cat's butt on the TV.
She loves the keyboard. Yeah. Constant battle.
But the white space, what I really hit with the white space thing is going back and looking at like one of the first things I'd written, where I was kind of excited at the time about the fact that you didn't have to put stuff in quotes, right? Like small things, like the fact that every time you're creating data, that data can just be a word. And so I wasn't looking for, I was like, and using parse itself to recognize the patterns and having the spec have the words with no quotes around them be the space, space line feed, and that was a interesting win. Now my standards are much higher. That's not very impressive anymore. So going back to it, I hit a number of problems. I mean, I have the commits going through of where I was trying to make this abstraction work, and there's a certain level of success in it, of cool things being shown, but then there's still these elements where it's hard to say that it's better than the JavaScript or whatever. And I think it's really important to ask this question of, if you start off with some premise and you go, here's the premise and here's why this is better than JavaScript. And you go, oh, okay. You start doing something and then you run into a wall, right? Well, you still got that premise stuck in your head, which is like, okay, but this is better than JavaScript, right? But then you keep getting stuck and then you go do something else and then you get stuck and you do something else and you get stuck. But you've still got somehow this thought lodged in your brain, well, I'm doing all this because it's better than JavaScript. But if you find after the end of all this and all your toil that this big quirky, non-modifiable, like you can't modify it in an obvious way if any of your requirements change thing, you're not better. It's not better than JavaScript because it's just twisted and you're not compatible with anybody. And so I think that just happens over and over to Rebel people and they don't really notice it or something. Like the red people especially don't seem to ever have any qualm. They don't stop and go, because they don't look at the solutions that are done in JavaScript. They don't use any other language. They just kind of have kept this thought ingrained in their brain, of the premise that it's better. And it's better for some things in small parts, small moments. But a program is much more than these small moments. So looking at the white space example is one of these confrontations of going like, where do you actually deliver on that actual promise? And what's stopping delivery of that promise? And so I hope people do help look at it. I think that my sort of realization, which I have a lot of times, is it's fun to sit around and fiddle bits, but you got to focus on that actually good, actually solving the problem. And if it turns out to be slow, well, maybe this year it's slow, next year it'll be fast.
That's kind of that's a little bit of my philosophy. Like I just try to get it to work, and my code just is sometimes like just rotten. But I mean, it's just like I need to express it and get a working solution, and then see how and then I just sort of keep chiseling away at the marble to try to get it what I want, But I like anything worth doing is worth doing badly, and then you just have to get over that, and then then you just keep refining and keep working at it. I mean the level of the degree of difficulty that I deal with is so much less than yours, Brian. I don't even know how you cope.
Well, no.
But for me, I can at least relate to the fact that I'm always having to get over my perfectionism and just saying, all right, I'm not a particularly skilled developer, but this code isn't going to write itself, and it's better to do it badly than to not do it.
Well, I just want to bring this up just in terms of mission statement, and for me, I think maybe I'm on the verge of solve. We're lucky if one or two foundational problems get solved a year, and then you always discover something else that asks a number of new questions. I think virtual binding, having a implementation of it at the beginning of this year that did something was a good move. We're still got the situation where things are not case insensitive, but I think they should be. I mean, I think that I've sort of convinced myself through the process I think it's been a good exercise to go through a phase of seeing what it's like to have it be case sensitive, to kind of know what you miss, and to see what broke. Number one, what broke and how, and then what do you miss, and what are the good arguments. And I think I found enough good arguments to and I should go back and write a post that explains why I think that yes, case and sensitivity is the right answer for this particular for binding. I don't know if it's the right answer for equal sign, but it's for binding at least. So I think I'm close to a potential, maybe, I don't know if I'll call it a breakthrough, but maybe breakthrough on how the lets will work, which is good because I think that for usability, being forced to declare your variables up at the top of the function is bad. It's not very usable. People are not... other languages don't make you do that. Anytime you do something that's inconvenient that every other language people use don't do.
Isn't that... I thought that was the case in JavaScript where you can add to...
No, they have let. I mean, the original JavaScript had var, but the problem with the var was that it was lifted, so a declaration of a var anywhere inside a function made it available through all of it. So you didn't have scoping. But
am I right in saying that JavaScript binds like per block?
It binds ahead. So it binds ahead per block. So you can name your variables. You can write a function in between two lets, and that function can use both the variable from before and after but that variable will be undefined until it gets assigned at the later point. But it'll still know what you defined for that block. So the visibility of the binding is to the code block. But var was visibility to the entire function, which made it kind of suck for isolating variables. But I'm talking about the ability to, hopefully, literally isolate variables to blocks with a let, which would be a lot, for binding purposes. We are still going with lifetime being indefinite. We don't have to. But as I said before, I think one of the big things that is going to be needed to make any sense of anything, if we're going to go with any kind of stackless, is having some kind of scoped lifetime, because otherwise, you start a generator, your generator is somewhere in the middle, you wander off, your generator doesn't finish, it locks whatever data is locked indefinitely, and scoping is really one of the few tools that you have, and people. The fact that Rebol doesn't have scope, people say, "Oh, Rebol has no scope." It's like it's more because it's not because scope is bad and it's trying to avoid it. It's because there was no way to do it. So the choice of how it worked was not based on any kind of notion of scope. What I can now do, and what I've been doing, is actually making it so that scope-oriented context follows blocks around as you move them, and you can have a function that takes 3 parameters, and those 3 parameters come in all with their own scope in the blocks. 3 blocks can be passed in, and each one can have a different notion of the scope that it's in, and it still carries that with it. And then you could add more, and you can run code in it, and I think some really interesting things could be possible out of this. It's not going to be fast. And this gets back to one of the things I don't really understand about Red, like I've said, which is, if you're someone who's really interested in speed, there are very few people who are really interested in speed but don't care anything about control or semantics. It's like Yeah, it's completely, or robustness or documentation or whatever, but certainly semantic fuzziness. It's like I want the fastest, completely fuzzy meaning system that there is. I want it to do something meaningless really quickly.
I don't care if it's quirky as long as it's fast.
Yeah, I don't really know that many applications of that.
I think if you're worried about what's the word I'm thinking of, like just scale. I think at the point where like the difference in speed matters at some kind of scale, it's like you need to find another way to solve that problem.
Yeah.
Or
Yeah, well, I mean, I am one reason I'm just sitting around. I'm fiddling bits, and I am fiddling bits to try and stop something from being, instead of taking up 2 megabytes, take up 1, right? And it's fiddling kind of on that level. And if
it doesn't fit in a floppy disk.
Yeah, well, I mean, doing a lot of fiddling, but I think that some of the stuff I'm working on right now seems pretty promising. Like it's the most promising seeming stuff that's come along in a while. The virtual binding has worked relatively well. And what I'm talking about doing is pushing it further with these lets. And if these lets work, and if they are, you might want to define the let out, even in C++, if you if you have a loop that loops 1,000,000 times, and you put a declaration of an object inside that loop, if it has a constructor and a destructor, it'll run each time through the block. That code will run each time through the block. Now, the nice thing about C++ is that the actual struct for the C++ structure only takes up memory once, because it knows it has that. I mean, it doesn't have the problem we have, which is that your actual fundamental structure of your code can be rearranged and blocks can move all over the place. They have a glued down structure. That for loop is always over that block, right? So they can say, okay, we know exactly how much, they build a cascade of how much memory, is used. And they know, okay, each time through this loop, we need an object that's this big, and they always use that same little spot of memory. But even in C++, even though they're reusing that memory over and over, well, number one, that object may have dynamic allocations. If that's an array, a vector, right? But if it's a vector that has tracking information that's as big as that structure, but the actual allocation is big, it has to do that each time through the loop. And it runs the constructor each time through the loop, runs the destructor each time through the loop. So when I start thinking about it more holistically, you start to realize, well, other languages, not languages, it may not seem like it, but other languages do make you sometimes, if you want to think to yourself, we're doing a lot of stuff each time in the loop, maybe you should move that variable outside the loop. And I think that's kind of the situation that we're going to look at is that the solution to lets will stop the annoying. I mean, the gathering from set words is something that might be useful in code golf or some scenarios, but because set words are dialect parts, they're used as object keys, they're used for all these other reasons, they were inflating the frame just by using an object. Shishin hit that limit. He had a ginormous object inside of a function. It gathered all the keys of the object to be part of the frame of the function as locals, and that you don't want that. And lets were less of a problem looking for the word let, but now we're looking for the word let, and you can't really redefine it. And so the dynamic let that is actually accruing contextual state for virtual binding as it goes. I mean, this stuff is stuff that didn't exist in Rebel, is not part of the original Rebel. You can say like, oh, this is un-Rebel-like. And you're like, because it works?
It's reformed Rebel.
Reformed. No, but yeah. So I just wanted to report that, there's some good news and that I think it might work. It's looking positive. Some things are looking positive. I'll know soon. I would have known maybe by now if we didn't have to meet. But yeah, so that's good. But I do think that we're going to start to look at something where people who like Graham who ask how fast is it compared to red or something, the answer to that is going to be slower. And if we want something to be fast, we should write that, that particular parts or service functions in is native code. I mean, that's red strategy too, right? If they find something that's not fast enough, write it in red system. And ours is that, but write it in C. And by working on the C code to the point where it's actually pretty decent, like I think the internal model, which has been worked on pretty heavily, is manageable to the point where we can write new natives pretty robustly, and they'll be fast and they'll be small, and the debugging is very good. Like there aren't a lot of mystery bugs, in Ren-c. There just aren't. Things are nailed down and caught pretty fast. The debugging is pretty good. So, long-winded way of saying, I think as long as everybody's on board with the concept that this is really going for the expressivity, it's going for these big questions about can you compose, can you abstract, does the binding, can you make something that's like a function but a little different, which is what I was doing with Whitespace, right? Whitespace is trying to make these functions that have a spec. Their spec is a language that actually has the opcode sequence as part of it. Like it's as if it's like part parse rule, part arguments. Here's the pattern, and then here's the part in the pattern that I want you to make into an argument, and then here's the body. And being able to make things like that to fit your situation is really powerful. So I think we shouldn't, I just want to make sure everybody's thinking along these lines and expecting along those lines. And so I want to see more of this parse machine project and understand it. So maybe that could be the next presentation. Maybe we could split on parse machines and Whitespace or something.
I still have to make it work for the things that it's the thing. Yeah. Well, I have a couple of things in the works. I actually have, because I did this for when I was kind of looking at the MySQL thing, is I actually have a SQL, very basic kind of SQL parser. That's kind of partly why I asked. It's like, it's not that difficult to write something that kind of parses traditional SQL, and I want to try and kind of bring all of these parts, like just JSON and other things, into this kind of one way of parsing, so that you can sort of flick between things. But let me say that again.
Yeah. Strong bad.
Yeah. Dear. Yeah, I'll work on having something for a month's time.
Do we want it in a month's time, or does anybody want it earlier?
3 weeks. Three weeks is a good number. 21 days.
Yeah, I think it's a good period of time.
3 weeks. 3 weeks it is.
All right, guys. Well, thanks a lot, Ed. And I think that the big move for you, it seems to me, is that move to putting it up, getting a test. We'll get test runs on Travis, and
Travis
have it.
What? Travis.com?
Or not Travis, sorry. GitHub Actions. Continuous integration of some form. And just have it so it runs through its tests, and, maybe you don't check all the output precisely that it matches, but maybe like the number of matches is something that could be returned well enough. And then, usually when things go wrong, it's like some change to the core, changes a function or changes in behavior. And so if I can fix it, then you don't have to. So that's an immediate benefit. But also, like I say, I think a number of us here, I think, would like to use it. And even if, it's not out of the gate going to be better than OS Query or whatever.
No, it won't.
But it's something that we can hack on and customize. If I can customize something like that with a bit of code for my filter condition, like you say, the parse rule to recognize things. Because I don't know, I can't write a regex to save my life, like without documentation certainly, and I don't usually feel like looking it up.
Yeah.
So I just don't do it. There's a threshold of I'm just gonna search for something that's kind of close that has the sub pattern in it, and then I'll just manually look through it before I'll go look and read regex. It has to cross a very, very big threshold. It has to be like 100 things has to hit the match pattern before I'm like, should I go try to remember, figure out what a regex for this is? If it's 99, I'm going to do it by hand. So
I use them not very sophisticated way, but just a clean data hygiene. I'm importing something and I have a bunch of like character entities or mojibak, which is the flipped characters or something from, that happens if UTF-8 gets screwed up. That kind of stuff, just fixing data.
By the way, regex is now in the HTML spec.
That doesn't help anyone.
Nope, but it's there. Because there's nothing like another mini language everywhere. They're everywhere.
So I thought that this kind of approach would be somewhat of interest to you, Chris, the dialect that I'm doing, because you can extend it and add your own clauses to, for example, create a static site generator or whatever. All stuff that you can do, and obviously you've done a million different ways, but this is a way of doing it in a few lines almost, and the only piece you need is the taxonomy to say, how you're going to create your pages and sew them up into a menu structure, into a tree structure, right? So anyway, it's not far from a very simple, using, I don't know many static site generators that are done using SQL syntax. I mean, the world doesn't necessarily need another static site generator, but you get the idea. I mean, like, there's all kinds of web stuff you can. I'm dying to get it good enough to wrap curl in, and I think that's doable, and stuff like that. I'd much rather use curl, use SQL syntax to grab stuff from curl or from webget, to download and parse and process data. Anyway,
well, hopefully you'll take to heart the mission to put it up, and we can start, collectively hacking on it. And yeah, there's huge, just all these questions. I'd love to just have the thread hit the questions of where do you use the lit words, where do you use the blocks, where do you use the ats, and
there are definitely spots where I felt like, God, I wish I had a different value. Like I could use the issue, but then with a string attached. Almost like binary, like the way binary looks, but it's actually its own word form. Like I think you've proposed in the past, Brian, some different forms of values, and I'm definitely at a point where, like, man, the only lexical forms that are available, value forms, are like I gotta,
tuples and paths. You can glue things together. You can start it with a word and then put a string after it. I think that finding ways to leverage tuples and paths is going to. I mean, I think I mentioned this the other day. I think that tuples with the dots just looks much better for field access than slashes do, and certainly helps mix out. Just go, oh, this is a function call versus this is a.
Yeah, I'll take a look at those.
A field selection, but other concepts of using them to create new combinations of values. Right now, they don't allow you to put binaries in tuples. There's no real reason not to let you do it, other than they'd probably be big. Not letting you do issues is sort of a artifact from before, when issues didn't have delimiters. Now that the issue char or token changes that, since pound quote whatever quote or pound open brace whatever close brace will, that will be token in my belief. And I think $. I mentioned I think taking $, open brace, whatever, close brace for binary is better. And then you have these forms for issues that can be used in quotes, which is nice, especially when you're trying to use them in APIs or on command lines or wherever where you're in quotes. You don't want to escape. Having the alternative to use curly braces is good. So we can talk about that, about how to make, I mean, you could say 5.km/s, 5 kilometers per second. I mean,
look at some of those things to get creative.
That's a little bit weird because it's like actually 5.k/s because the dot binds higher, binds more closely. But you don't have to be bothered by that any more than you have to be bothered by how a string represents itself. You can say, I mean, we can actually have a function that says, okay, decode. Don't use the default evaluator decoding of this path thing. Give me that path, break it down in a way, synthesize it in a way that would make the slashes lower priority than the dots. And that we can have that as a function, and there's no harm in that, right? I mean, that's just like parsing, right? So if it looks good to you on screen, if you like the notation, you might think of leveraging it. I mean, if it's not running through the evaluator and it's just looking at a picture, then no reason not to use it. All right. Well, that's good. I guess we've talked for 2.5 hours. So
Perfect.
Good to see you guys. Glad Julio could make it. And it was cool to see the captions run in real time. I like the.
That's interesting.
Yes, it's getting.
Love to know if they were translated.
Oh, I didn't even see the.
You didn't click on the captions.
Yes.
Click turn on captions, and it does it in real time. And as long as you don't say Ren-c, it will know what you're talking about.
Oh damn! I should have put the captions on.
Yeah, well, we live in the future almost. Like we're almost there.
Oh damn!
Okay.
Next time.
All right.
Okay.
Enjoy the rest of the week, guys.
Thanks, Ed.